Hey TechKnowStuds! We've talked quite a bit now about transistors and microprocessors and integrated circuits, and how these microprocessors and integrated circuits use a lot of these transistors within these microprocessors. So now let's take that to another degree. Let's take a look at how these microprocessors work and why they're so important, and why do we consider them like little mini switches. Our story begins with an element called silicon. Silicon is a basic element that's found on the periodic table. And so what silicon is, in fact, you might have heard of Silicon Valley, and that's just because it's a big tech hub here in the United States. So silicon is an element that we build these transistors out of. Silicon is a very common element, and you can find silicon even in sand. But there's something really special about silicon that doesn't really share it with much other elements on the periodic table. And that is, most stuff that you find on the periodic table are either they're conductive materials, meaning electricity can flow through it, like copper, or they're not conductive, like glass, and they're called an insulator. Well, silicon is unique in many ways because we can add a couple substances to it to make it a semiconductor. That is, sometimes it will conduct electricity and sometimes it won't conduct electricity. So this is what a transistor looks like, and several of the components in here are actually made of silicon. And what we can say is, what we'll do is we'll put power on one side. So we've got power coming in on one side, and then we've got it grounded out the other side, or maybe it's powering something, or there's something on, maybe it's a light bulb, there's something on the other side. Now, electricity is not going to flow through here until we apply power right here. And we'll put a plus right there as we're applying power. Or actually, what we'll do is, because who knows if this is 5 volts, maybe it's 10 volts, maybe it's 12 volts, maybe it's 120 volts. Who knows what this is? So we're just going to, instead of put power, we're gonna say 1 there. If we have a 1 representing just this power element here, then we'll have electricity flow through that silicon to the other side, and we'll get a 1 as an output over here. However, if we don't have any electricity applied here, what's going to happen is it's going to change the makeup of this area right here, and electricity won't flow through, and we're going to get a 0 on the other side. I'm going to change the way this looks and make it look like a button instead, like a switch, because that's essentially what it is. We press a 1 right here, so we're pressing down on the button. That would be equivalent to a 1. That means we're sending voltage to it. Then power is going to flow through here because it's going to make a contact there. However, if we're going to not press this button, or a 0, that means electricity can't flow through this conductor right here. They can't flow through that. So that's why, if you can see it, there's actually 3 different prongs to this. We have a power that we apply to it, and then we have the output of it, of a 1 or a 0, and then we have the input to this of a 1 or 0. And if we put a 1 as an input into it, then power flows from the positive to the output. And if we put a 0 into this, then the power can't flow from the positive to the output of this. And the next thing we're going to do is we're going to take those transistors then and start making something called gates out of it.